everyone, today we're going to look at proportional and non-proportional relationships. Linear relationships will either be proportional or non-proportional. Let me get a different color here. Proportional or non-proportional. A proportional relationship means that there will be a constant ratio, and that's ratio, between the values of x and y. Now, we're going to fill out this graphic on the differences between a proportional relationship and a non-proportional one. So on a graph, if you want to sketch a quick x and y axis, it does not have to be perfect. Just a quick sketch for you. And I'm going to change the color. Your graph is going to go through that middle where the x and y meet. It's called the origin. It should be a straight line coming out of there. It's not very straight, but the key part is it's going to go through that origin. Goes. All right, so I took out goes and I just wanted to put origin. So what that origin is 0, 0. That's what the origin stands for. Now, if we were given a table, maybe x and y, the table could be laying flat also, but maybe we have -1, 1, 0, 0, 1, 2, or 1. Let's see, 1, 1, 2, 2. That's an easy kind of table. You can see that it goes through the origin. An equation is going to be y equals mx, where m is your slope. So maybe, for example, y equals 2x. Or for another example, y equals -1/3. Oh, there, I finished my 3. 1/3 x. All right. And a verbal description. The verbal description would be like it has a constant rate of change. Has constant rate of change. And then, of course, it goes through origin. I know we're at the bottom of our paper. So let's go to the next one. Now, a non-proportional relationship. Let me change colors here. The graph, if we sketch a quick graph, can be anywhere on this y-axis except for the 0, 0. So I'm going to draw a negative sloping line, and it's going to look like this. You can tell it definitely has a y-intercept other than 0, 0. My equation will actually be what we're used to, y equals mx plus b. And if, for example, we can plug in our slope and our y-intercept, our slope might be -2x and then plus 3. Okay, we have a plus b over here. The main difference is this part right here. From our last example, which let me show you, notice how it didn't have anything behind it. And now it has a +3, or it can have a -1 or anything like that, except it can't go through the origin. Remember, that's the key. So for the table of values, let's do one where it's kind of sideways. We did one as an example on the other one where it was a up and down table. On this one, maybe it's -1, 3, 0, 4, 1, 5, and so on. You do 2, 6. If you notice, again, when x is 0, that is your y-intercepts. So it actually has a number there. And for the last, the verbal description, it has y-intercept. And you can shorten that to int. It has y-intercept that is not 0, 0, or Yeah, let's go with that. Let me erase all that. All right, let's go to the next example where we're actually going to do some problems. So Hillary's looking for a gym to join. It says that Gym A offers a membership for $25 a month with no sign-up fee. I'm going to go ahead and write that equation. So y equals, and it says $20 a month. That's 25x. Y equals 25x. That a month means per month or each month. Gym B, I'm going to use red, offers a membership of $20 a month with a $10 sign-up fee. So we're going to have a little bit extra. We'll have y equals 10x. And then, oh my goodness. Hopefully y'all caught what I did wrong. It is supposed to be a 20x. $20 a month plus the $10 sign-up fee. The $10 sign-up fee is your y-intercept. All right, and so our question here on the bottom says, what gym shows a proportional relationship between x and y in the equation? So remember, for a proportional one, we actually want gym A. It does not have a y-intercept. It has a meaning like it doesn't have this extra bit that gym B has. If we wanted to, we could put a +0 right here, but you'll never see it written with a +0. So that's why I don't normally write it. But just know it does go through your origin. Next problem. So now we're going to complete that table. So I'm going to fill in, what color did we use on the last one? Blue and red. So for gym A, I'm going to write it up here above it. Y equals 25x. And we have 20x plus 10. So then on gym B, I'm going to write up here, y equals 20x plus 10. Alrighty, so if we're filling in this table, we're going to plug in a 25 times 0 where this x is. And 25 times 0, 0. 25 times 1, 25. 25 times 2, you can use a calculator. 25 times 3, 75. You can also think about quarters. Quarters are worth 25 cents. If you have 3 of them, you have 75 cents. All right, back to our equation. Now on this one, we're going to plug in our x's still right here, but we need to remember to add our y-intercept, our 10. So 20 times 0 is 0. 0 plus 10 will give us our 10. 20 times 1 is 20. 20 plus 10 is 30. 20 times 2 is 40. 40 plus 10 is 50. Notice how it's going up by 20 every time. So guess what? This one will be 70. Okay. Which gym shows a proportional relationship? Again, based on this table. Well, we already figured that out earlier. Okay, we had gym A. So we're going to keep with that one. Now on this example, we're going to graph it. So we have our coordinates right up here. Let me get back to blue for gym A. I'm going to put a dot at 0, 0. So let's see if I can do this or if it's going to look really bad. Oh, I'm off a little. And then 1 and 25. So kind of in between 20 and 30. 2 and 50. And 3 and 75. I will draw a line to try to connect these points as straight as possible as I can. Let me switch to red. Again, we're going to graph these points. So 0, 10. I'm going to start on the 10 on the y-axis. 1, 30, 2, and 50, and 3, and 70. All right, so you can tell because it goes through 0, 0, gym A is proportional. Gym B starts at a y-intercept that is not 0, so it is non-proportional. Last slide. All right, so go through here and label. Is it proportional? Is it non-proportional? If you want to, you can totally pause and come back, and we will go over the answers. All right, welcome back. So instead of just writing it completely, I'm going to put a P or an NP. This one is proportional. Remember, it doesn't have any plus whatever or minus something behind it. We're going to skip this one for a second. Number 6, straight line. It hits way up here, not at the 0, 0. It is non-proportional. Okay. Does it go through the intersection of 0, 0? Absolutely. Is it a crazy, weird, curvy graph? Yes, it is. But it does go through 0, 0. We're going to put it as proportional. Let's look at number 7. Jen orders balloons for 99 cents each, plus there's a shipping fee. If I were to write that equation, I would have 0.99x plus the shipping fee of $2.79. That makes this non-proportional. All right, the last ones we have are tables. If we have a table of values, our ratio needs to stay the same. And what this means, let me pull up Desmos really quick for a calculator. So when we go and use this, I'm going to look at what is my x divided by my y for every single one of these on the table. So -9 divided by 13.5. Oh my goodness gracious. Okay, now I can type in 13.5. And you get -0.666 or -2/3. I'm going to write that down. -2/3. Now, I got to see if this one will also give me -2/3. So, clear, -8 divided by 12. It does give me -2/3. I could keep the decimal if I wanted to. Try this next one. -7 and 10.5. -7 divided by 10.5. Again. So we want to check the entire table because somehow someone will throw in something that's wrong right there. So, and then of course, -6 divided by 9, we know that's a -2/3 when we simplify it. We show that there is a constant ratio through this whole table. And so, yes, it is proportional. If you want to do a P somewhere in that box. So let's try number 9. I'm going to get a different color because blue is covering this page. So what is 8 divided by 18? 0.4 repeating. So I'm going to leave it as a decimal. 0.4 as a fraction. Oh, what it is. 4/9. 10 divided by 20. 10 divided by 20 is 0.5. I can stop right now because these two numbers are not the same. That means it is non-proportional. Now, the others in the table might be 0.5 or 0.4. I don't know. I don't even have to work on because we already know it's not proportional. All right. Well, if you still have questions, contact Miss Hill or myself. Have a great day.